Hi guys, welcome to this Wintellect webinar where today we're going to be talking about building and maintaining containers on Microsoft Azure. I'm the host of today's webinar. I'm Blaze Stewart, architect at Wintellect. I'm a Microsoft MCSC, PCSA, Microsoft MVP, MCT, all those things, that bunch of letters, and I have a bunch of certifications. So yeah, I just kind of live and breathe Microsoft all day. So that's what I do. But I also love to talk about Azure and containers and where those two kind of meet up. And that's what we're going to be talking about today, specifically around building and maintaining, managing containers on Azure. A little bit about Wintellect and just who we are. Wintellect is now, I don't have it now with when I built this deck, we are now part of a company called Amacera, and Amacera is going through a merger with us, and so we have consulting, training, and we are a managed service partner as well, so that we can help you maintain your workloads on Azure if you don't want the headaches of dealing with that yourself. So we are going to be adding some more to this slide, but historically, Wintellect has been a consulting and training company. Now we're going to add the CSP to the side of the business now as well, so we can talk about architecture analysis and design and consulting and help you get your stuff up and running, build software, that kind of thing. And then the training aspects, of course, is helping you skill up on all of the latest and greatest Microsoft tech and helping you get your guys ready to build stuff to put on Azure and other place and using the technologies therein as well. So kind of what we do, and we are excited to be a part of the Amacera family now, and we will be certainly talking about those kinds of offerings in future videos and webinars. Anyway, let's dive right in and get right into what we're talking about today, and that is dealing with containers, builds, and talking about how to manage those on Azure. So fundamentally, a container workflow looks something like this, where I have a container build environment and I have a container registry, and then I have a container environment, a container runtime environment, which is going to be where I'm going to run my containers. So a build environment starts with a Docker file, then any other files that you might have associated with that. That could be your scripts, your program, the builds that you might be doing. And then, within the context of a build environment with Docker, a Docker file is you run a command Docker build, and then that takes the Docker file, which is a script, and uses that as instructions on how to build a Docker image.
Hey, Blaze.
Yes.
I think you're sharing the wrong screen.
Am I sharing presenter view?
Yeah.
Oh, well, let me switch that. Thanks for calling that out. Let's see, I hit share screen. You see share this monitor. Is that better?
Yep.
Perfect, thanks. I just hit share screen and I guess I started sharing that one. Not a problem. But in any case, we have a build environment, container registry, and a container environment. We run Docker build that takes our Docker file and runs it as a script and then creates a container image from that. Then we run a Docker push, and then that takes it and puts it up into a container registry. And then once it's in the container registry, I can access it from container environments that might use that. So that container registry could be Docker Hub, it could be Azure Container Registry, which is the one we're going to be looking at today, or any one of the other ones that are available. And then from there, you run some kind of deploy command, and it takes the image off the registry, downloads it to your container environment, and then takes the image and turns that into an actual container to run your application. So this is the basic workflow that all container workflows use. Regardless of which way I'm going to show you how to do today, this is one of the major approaches that we're going to have for this. So just a few things that we have here are related to this. A couple of things. Yes, the question always gets asked, will this be available later on? Yes, we'll put it on our YouTube channel. Please do ask questions. Just put them in the question box, and as we go through that, we'll have Q&A at the end, and you can have questions there. I forgot to mention that at the start. In any case, because I was too anxious to jump right into this. In any case, let's just go right back to what we're talking about here, because for the container workflow, that's pretty straightforward. Most folks that have dealt with containers understand this workflow, at least at some level, because it's very familiar. You can do it right in the context of a local Docker environment, and you can deploy those locally, and you can spin these up easily on whatever container environment you're running in, be it Kubernetes, Azure App Services, Azure Container Instances, or some kind of the other container runtime that you might be using on another cloud or on-premise. There's a lot of different options for running containers. So once you have that container built and it's running, that's really what you're aiming for. So we're mostly going to be looking at this process through the lens of automation, more like DevOps on the ways that we're going to be looking at today, and that's the building container images, not just doing it on a local environment, but we're going to be looking at it from that angle, and we're going to be looking at getting it up into a container registry. We're not going to be looking a whole lot at deployment, but deployment is kind of the downstream side of this. So we're mostly concerned about the building of containers. So the first thing that I want to mention is on container management and the Azure context is Azure Container Registry. Azure Container Registry is Microsoft's first-party solution for containers on Azure. So if you want to have containers hosted in a private solution rather than using a public one like Docker Hub or a GitHub image registry, you can use Azure Container Registry to have a private hosted container registry that works just like Docker Hub does for all of your container needs. And you can sign up for this on Azure. In fact, I'm going to go to this, but it gives you a way to stand up your containers and use those in Azure so that you can use these with whether it be a private endpoint or a public endpoint. A private endpoint being that it's only accessible on your Azure VNets or across a VPN into a private network, so it's not publicly accessible, or you can expose it as a public endpoint and access it over the internet, and then that becomes more available. You still have to have credentials to access it though. It also supports building containers, which is one thing I want to look at with Azure Container Registry, and you can also have webhooks when new containers are posted. So let's go over to the Azure portal and take a look at this, and we're going to be building an instance of this. Let me pull up the portal over here. I'm going to pull this window up over onto my desktop here, and I have a this is the Azure portal, and I'm going to be using a resource group. I think I already have it created called. Let's just create a new one. Let's call it ACR demo, and I'm going to put it in East US region. I'm going to create a new Azure resource group. And I'm going to go to this resource group, and I'm going to create an Azure Container Registry right here. This is very easy to do in the context of Azure. So I'm going to click Add, and then go to Containers, click on Container Registry, and I'm just going to stand one of these up. This doesn't take long at all to create. I'm going to call it Blaze ACR, and that's Blaze Azure Container Registry. I'm going to put it in the East region, East US region. Where is East US? There it is. And I'm not going to turn. I'm going to select the premium SKU. This is where I can set up private and public endpoints. So if I wanted to have a public endpoint or private endpoint, I could stand this up on a private network, and it just as a private endpoint that's only accessible on my private network. This is accessible on a public over the internet. If I wanted to encrypt things with keys, I can do that, but I'm going to leave that disabled because this is going to be short-lived. And then tags, I can tag it, and then once I review and create it, I can go ahead and spit that for deployment. So again, this is very easy to do for spinning one of these up. You can create these with ARM templates, but typically you're going to have one of these as a place for dropping in your artifacts in Azure. So Azure Container Registry is kind of grand central station for doing all things container management on Azure. So this is where I'm going to be sending all of my images that I'm going to be building today. And I can control access through access keys for encryption, integrate Azure AD with this, and this is where I can look at my repositories and all the manifests for. I don't have any images in here in my repositories. I can set up webhooks if I want to set up webhooks to have notifications sent to other systems downstream of this. Replication, if I want to do geo-replication inside of this, I can create geo-replication across the globe using Azure Container Registry just by simply clicking on this map and say, replicate to this region, replicate to that region, and it will create a copy of my registry in another region without having to spin that up and have to create some kind of syncing mechanism between it all. Under the hood, Azure Container Registry is using a storage account to do all this with. It's just applying some stuff on top of that to allow you to do this replication across the globe wherever you might want to do. And then this is what I also want to talk about right here. And this is mostly what we're going to be looking at today, and that's building tasks on ACR, which is a way of automating builds using Azure Container Registry. And this is very easy to set up and use. So it's a very tempting solution to use for a number of reasons, but one of them is just it's pure simplicity, because to create this doesn't take much effort. So let's go back over to the deck for a second and take a look at Azure Container Registry Task, which is the automation piece built into ACR. So Azure ACR can be triggered by a container builds inside, can trigger a build container builds inside of Azure Container Registry. And so you can have a GitHub repo or an Azure DevOps experience. And what you can do with this is you can say, hey, every time I push to a GitHub repo, I want to trigger a build in Azure Container Registry. That doesn't require an Azure Container Registry. It doesn't require a GitHub action to do that. We're going to look at that story in a minute. It just requires that I set up the synchronization between GitHub and Azure Container Registry. And once I set that up, I'm golden. I can use Azure Container Registry to build all my images. And it also supports multi-platform. You'll be able to detect that based on the images that you use inside of your Docker files. So if it's a Windows container, it can do that. It can build Linux containers, and it can also build ARM-based containers as well using QEMU. So if you want to do ARM builds for like Raspberry Pis or other ARM-based systems, you can do that in Azure Container Registry. And the tasks, and this will automatically do things like versioning and tagging and that kind of thing for you. So this is very easy to do. So let's go back over to our browser. I'm going to show you how to set this up. But first, I want to look at the repository that I'm going to be using for the demos today, and that's this. I have one here called DOS game, and I'm going to delete this DOS game. I'm going to reset this up later. I'm going to delete this file, but this is this workflow right here, because I'm going to recreate it in a minute. But this right here is the repository I'm going to be using for my builds from. And this has got Azure, it's got some Azure pipelines in it that I'm not going to be really using for this. Actually, I'm going to delete these out in just a second to clean this up some. And then here's my Docker file that I'm using for my build. It's not a trivial Docker file, but it does do stuff to set up a instance of DOSBox, which is an old DOS game emulator that will allow me to run old DOS games inside of a container. And then it lets me stream that result back to a browser so I can play it inside of a browser. So I'm going to go ahead and I'm going to clean this up a little bit and just go ahead and delete some files here and just get rid of some of these old pipelines, because we're going to be recreating some of this in a minute. And let's commit that, and let's clean out this workflow right here, because I don't need it anymore. I'm just going to throw it away, and because I'm about to redo it. So yeah, clean up my repository. I don't have anything but the Kubernetes manifest file, my Docker file, a README, and this is some Terraform, I think, templates here. Yeah, no, that's more Kubernetes stuff, and this is just the installer for the game I want to use in this demo here. So the first thing I want to do is set this up inside of Azure Container Registry to connect to this particular instance of this particular repository inside of GitHub. So to do that, all I really need to do is run something inside the Azure CLI. So that command is pretty straightforward to run. And the command is going to look like this. Let me pull this. I'm gonna pull this command up and paste it over here. I have to scrub it because it's got a personal access token in it for GitHub. But in any case, what I'm going to do is I'm going to paste the command here and show you what it looks like. So this is the command to create a task. You can't do this on the portal yet, but the command is so simple to run inside of the Cloud Shell in Azure. So I started up a Cloud Shell, and I'm just doing AZ ACR task create, and you can run this from your desktop as well. And I'm just saying use this registry, Blaze ACR, the name of the build right there. This is giving me the image name, so Keen ACR, and this is the context, which is that GitHub repo, and this is the branch I was on right here on the master branch, and it's looking for the path to the Docker file, and then here's the credentials that I need to paste in. I didn't paste it here because the credentials is a personal access token from GitHub, which you can get that simply by going up here to your settings and going down to developer settings and creating a personal access token. and I already have this one set up right here. I'm not going to recreate it because it gives you the thing about personal access tokens is they're global. They're not specific to a repository, so I can't give you this without compromising my entire GitHub. So I'm not going to do that. But what I am going to do is, I'm not going to show you. What I'm going to do is I'm going to pull this over here, run the command with the personal access token so you can't see it, but show you the results of it anyway. So, and so this will allow me to create this. And once you create it, now I'm gonna pull this back over here so you can see it. You'll get output that looks like this. And then inside of my tasks, I can minimize this. Now inside of my task, I should see a new task build. And so what this has done is it's connected my ACR, my Azure Container Registry instance, using an Azure Container Registry instance task to my GitHub repository. And so anytime I do a change in the repository, I should be able to trigger a build. So let's just do a trivial change right here. Let's change the README right here. Let's edit the README. And I'm going to take some of these, let's just make a trivial change to the README. And that should be sufficient to trigger a build here. And I committed it. And so that should be now building right here. So if I look at runs, I should see a run running right here. And so with a task, I can trigger a build just by making a push into my registry, a commit there. And now, if I want to see the output from that, I have logs that are streaming back to the browser right here. It's not streaming, but it's sending the logs back to the browser. I can check on the output from the build as it goes forward in the logs. I can't, I would have to refresh that or pull it up again to see progress. And you can see that it's building the image. And when that's done, I should have a new repository here as soon as that's done. So this one takes about 2.5 minutes to build or so, depending on what I'm doing. So that is how I would use the same flow, that is the same task to create a container image inside of Container Registry using tasks. Now, the downside of using Azure Container Registry task is that it doesn't allow me to do anything other than build. So it's mostly just aimed squarely at builds. If I wanted to have something do a deployment, then I would need to set up a deployment pipeline that's invoked by way of a webhook. So you can set up a webhook to invoke something like a deployment pipeline or something that would go out and tell your container runtime to either refresh the container or spin up a new instance of it or whatever it might be that you might have that's triggered by a webhook out of Azure Container Registry tasks. I've built pipelines using tasks as the build and use webhooks to invoke something like Azure Container instances to reload the instance to reload a container once it was pushed that way. And I think I used Azure Automation for that. So because Azure Automation supports webhooks. So that's one possible solution for that. You could use something like Logic Apps, or you could use Azure DevOps or any other thing that supports webhooks that you could use to trigger the output from a build on tasks for deploying your container if you wanted to get that sophisticated with it. So let's talk about the next kind of build, and that's going to be using GitHub Actions. Now, GitHub Actions are another way to automate tasks on Azure as well. So I have GitHub Actions are built into GitHub itself. So GitHub Actions give me a YAML-based approach for running tasks. And again, you can build, test, deploy, do all kinds of things with actions. And the way that this works is based on an event that happens inside of a repository, such as a push, a pull request, whatever it might be. You can invoke an action, and then that action will do something. And one of those potential actions is build a container. And so it's got full support for building and pushing container images into a repository. And so that's what I really want to show you here. It's just a YAML-based approach, so it's not as easy to set up as something like tasks, but it's not hard to do either. So let's go back over to that GitHub repository, and let's use the GitHub repository to create an action that will take the Docker file that there, build an image and put it into my Azure Container Registry. And we're going to use this repository to do the exact same thing here. So to do that, I'm just going to click on Actions right here, and these are the ones that I had, from that I had built already from previous builds on this, because I just deleted it. But I'm going to do a new workflow, and this is going to be my my new workflow here. And I'm going to set up a workflow. This is just going to drop in some code here. I am not real interested in that code. I'm actually going to replace that with this code. Now, this code right here is just a single job. It doesn't really do much. It just builds and pushes a container image using Docker. So this is very easy to set up. If again, nothing to it. Build and push Azure Container Registry, and then anytime something happens on push, this will get triggered. And this is referencing secrets inside of my repository. So you can nest secrets inside of this that act as parameters. So if you don't want to hard code things like users and passwords into your workflows, you can then use secrets to parameterize that. So let me save this right here, and let's call it ACR and save. Commit that new file, and that's actually going to trigger another build on ACR, by the way, by just doing that commit right there. And I'm going to go over here to my settings, and I'm going to go down to my secrets right here, and this is where I had these set up. So if I wanted to change the values of these, I need to. So what I'm going to do is I'm going to pull these values out of Azure Container Registry using some of these values that I can find here inside of my access keys. And so what you can do is you can turn on admin user right here, and this will give you some generated passwords. So I need this field, and this field, and put that into my secrets on GitHub. So let's start with the password. I'm gonna copy that, and I'm gonna edit this, update the password here with that value. I don't mind showing you this because after I get done with this webinar, I'm gonna delete this. And then the server login right there. I'm going to update this, and I'm going to update that value. And then for the user, I'm going to update this. I'm going to grab that right here, admin user, and paste it in and update that secret. And so now I have populated these secrets right here. Now I should be able to come back over here, do a trivial change on this again, trigger a new, and this will trigger a new, this should trigger that pipeline to build. So let's update the README, and then I should be able to come over here to Actions and see it actually run. Now this one right here is this one will probably fail because those secrets were invalid, and so it's not going to be able to push it. It actually will build the image, but it'll die on the push. This one right here should work fine because the secrets are updated now, and so that's what I'm expecting. So as soon as this one builds, I should be able to go to my registry and see those container images actually build. So let's go over and check on it. I should actually see two builds for the trigger that happened from GitHub Actions. If I go in my repositories and for my task, I should be able to see the runs right here. I have 3 now because those changes that I made in the repository by adding a workflow, a GitHub action, triggered this second build right here. And the third one I made by adding the README added this third one right here. All of these right here are having on tasks in parallel with the actual build that's building out the image on GitHub itself using a GitHub action. So it's 2 different builds happening from the same repository. It's building the exact same image. It's just doing it in 2 different means. One of them is doing using tasks. One of them is using GitHub Actions. The end result is the same. I still get an image in my repository. I use 2 different repositories for this. One is for the one that's being built by tasks. The other one is the one that's being used by GitHub Actions. But I'm going to show you a third way to do this. So, and then once we wrap that up, I'm going to look at a potential pros and cons of which way you might want to use and why you might want to use it as well, to kind of show you which build process do I care about. Why do I care about, why would I use tasks? Why would I use GitHub Actions? Why would I use the third one, which is Azure DevOps? Let's see if that build's done yet. Not yet, but we'll come back to it and check on it in a minute. As soon as it finishes, it's still running. So to do this, I'm gonna hop over to Azure DevOps. and look at my Azure DevOps here. I set this one up the last time I ran this demo, but I'm gonna create a new project here. I'm gonna call it Blazes build. And this is just a new project. I'm not interested in using repos in this particular project. I'm mostly interested in using pipelines, because the great thing about Azure DevOps is it can connect to multiple different kinds of code sources. I don't have to use repositories to use pipelines in Azure DevOps. I don't have to use pipelines to use the repositories. I don't have to use the repositories to use boards. Azure DevOps is a set of tools that are come together. They're all tightly integrated with one another, but each one of them can also be used independent of the other ones as well. So I don't have to use repositories. In fact, I'm just going to use pipelines for this particular demo here, and I'm going to set up a pipeline to use a GitHub repository as my source code. So very easy to do that. So I'm going to come over here and create a pipeline right here. Now, the pipeline I'm going to create right here is going to use GitHub, but notice the other ones I have here. I have Azure Get repos for Git. I have Bitbucket. That's from Atlassian. I can use GitHub, the cloud offering. I can use the enterprise server, which is on premise. Other Git, that's just generic, Git, whatever it might be, Subversion. If you go to the classic editor, which you can use this for building these as well, you have the same options right here. And if you wanted to use those, you can as well. You can use this to build containers, or you can use the classic one. This is the classic editor, or you can use the new YAML-based creator, which is the one I'm going to use for today, which is the one that Microsoft is kind of pushing folks to more and more as they kind of move away from this old visual designer, the classic editor. So I'm going to choose GitHub right here. And GitHub is going to be the source of my code right here. And this is already plugged into my GitHub repositories. I've already associated my Azure DevOps with GitHub. If you hadn't done that yet, it'll ask you for that integration. And so I've already done that. And because I've already done that, I can just select the repository I'm going to use, which is this DOS game one right here. Now, what it's going to do is analyze your repository and make suggestions based on the whatever might be in a repository. It found a Docker file, so it's going to throw up, build a Docker image, build an Azure Container Registry and push to that. It also has Kubernetes, because it detected I had Kubernetes manifest files in there. But if none of those match my use case, of course, with this, there's a ton of templates for other types of builds as well. So if you wanted to have an empty one, you can definitely do that. But you can also use one of these other build pipelines and then edit these once you do that. This one most closely matches what I'm going to be doing. So I'm going to select this pipeline right here, build and push an image to Azure Container Registry. That is not hard to set up. And so this is going to go load my subscriptions, and I'm basically just going to choose, I'm going to log in my subscription. And then as part of that, it's going to allow me to choose the Azure Container Registry as soon as I get logged in here. It's going to allow me to choose the container registry, Blaze ACR. The image name I'm going to use, I'm just going to call this, DevOps or ADO Keen, maybe something like that. ADO Keen. And that's the Docker file I'm going to use. It's in the root. And so that's all the parameters I need to do. I hit validate and configure. And that's just going to create a connection, a service connection to my Azure DevOps instance, from a DevOps instance over to my container registry. And then it's going to pre-populate this template with what I need to build it. And so again, very easy to do right out of the box. I don't have to really configure anything. It is possible to set this all up manually. You don't have to do the automation like I did, but I did it all through just a wizard really, and it created a YAML file that's going to allow me to build and push an image into Azure Container Registry based on a push into Azure, into a GitHub repository. The same thing could be triggered from any repository though. It's not unique to GitHub. It'll work with other Git repos that we listed there. But this one is going to be based off that GitHub repo that I built the other two methods of doing the exact same thing with. So if I hit save, like this. I'm just going to save this. I'm going to save this out, and then it's going to create the pipeline. Then what I'm going to do is I'm going to go over to my GitHub repo, and I'm going to do yet another just trivial change and watch it trigger all three of them running at the same time. So it should trigger the GitHub action, should trigger my Azure DevOps build and the ACR to build all at the same time. So I'm building the same image three times all at the same time. So I think I have that pulled up right here. Let's do over here back to my GitHub repo. Let's do a trivial change here, and then let's just we can see what's going on here. And let's just do simple change like that. Commit it, and we should be off to the races. So I should be able to see a new build right here. That last one ran just fine. I can see the output for that. That new one's been queued up. If I drill down into this, it just shows me the output from that. So you'll build it from that, so you can see here's the output, et cetera. You can see the build right here, the output from the build and so on in the logs on GitHub. That's the GitHub Actions build. If I wanted to see it in the ACR task build, I would see the exact same run going for a fifth time currently. So I have two builds going on there. That's from when I actually created. This one happened when I created the pipeline, because it actually dropped a new file out there. It dropped a new file out there in my repository, so that triggered a build. And there's the push from GitHub on the task. Where was I? I was on the task right here. So the runs right here. So this one was triggered when I created the pipeline in Azure DevOps. This one was triggered when I actually changed the README in DevOps. And so the first one and this one should be running right about now, right here, triggered by that same build. No runs yet. It didn't trigger it for some reason. Let's just go ahead and trigger it manually then. I don't have I probably didn't set the trigger. Pipelines in your region may be impacted. Yeah, maybe it could be just I don't think I didn't set the trigger up. That's what I didn't trigger on build. But in any case, not a big deal. I can watch it build right here. And this is just using Azure DevOps to build the exact same container. So this one is going to be queuing up a build. So why that builds, let's go and look at let's go look at the last slide, which is going to be kind of put a nice bow on this to kind of look at, compare and contrast these while those are building in the background. Then I'll just deploy the container to Azure Container Instances so that we can see actually what I'm building here as well. So the three ways to do this that we saw today, we looked at Azure Container Registry tasks, we looked at GitHub Actions, we looked at Azure DevOps, all three different ways to build containers on Azure. And though they can all deliver container images into an Azure Container Registry, which we can use to manage our containers on Azure. And so all three of them integrate well with Azure Container Registry and container workflows. So what are the advantages and disadvantages of doing these? What I love about Task is this one is, like I said, easy to set up. It's got tight integration with GitHub and Azure DevOps. Very easy to spin up and use this one. So again, just a single entry on the command line, and that one will create the task very quickly and effectively without having to deal with any kind of YAML files. It just builds it. The disadvantages, like I said, there's no CD, there's no built-in deployment pipelines that are part of this. So you'd have to use something external to that for automation for downstream tasks. You'd have to trigger it by a webhook. So the other thing I don't like about this one is that it uses a personal access token, and that could be a security problem. If you have a way of guarding that with a secret, then great. Then that's going to work fine for you. That's only when you create it, though. It doesn't really matter. After you create it, you can kind of throw away that. You can discard that. It's only a once and done type thing. But it is a personal access token for accessing your GitHub repos. And that's a universal, so you can't just create one for a specific registry. So that's our repository, so it can get a little bit dicey there. The GitHub Actions side, I like this one because it's easy to integrate with new and existing GitHub repos. if you get using GitHub, which many people are, it's easy to spin it up and use it. It didn't take much to set that up. And there's just tons and tons of templates for this. Docker is just one way of building things, and there's a lot of documentation, a lot of examples, a lot of ways to get this working. And the platform is solid. There's very few bugs in it. I really like GitHub Actions for that. The basic downside of this, there's no clear distinction between CI and CD in GitHub Actions. It's like you can easily mix and match them like in the same pipeline, which generally is not a good thing to do. You want your builds to separate from your deployments. GitHub Actions doesn't give you a distinction between those, so you can really get wrapped around the axle with that. And it's really limited to just GitHub, and so it doesn't allow you to integrate with other repositories. Now, it is possible to sync other repositories with GitHub if you want to use Actions. So you can do that. So like if you want to do an automation build, if I'm running a GitHub repository on premise and I want to use GitHub Actions for other things, I can trigger something to just simply do a pull push from my repository into another repository with Git, and it's very flexible. It allows you to do that, and so that I can take advantage of GitHub Actions. Possible, but it's just not in a part of the out-of-box experience. So there are workarounds for it. One thing I love about Azure DevOps is it just supports so many different sources for code. You can use Bitbucket, GitHub, ADO, Azure DevOps Get, SVN, and others. And there's a clear distinction between builds and deployment pipelines in Azure DevOps. So it's a separate pipeline for deployments than it is for builds. And they do a good job about keeping those separation of concerns discrete. Why I think GitHub Actions doesn't do quite a good job as that, as Azure DevOps does. There's also a lot of other things about Azure DevOps I really like, and that's because it's an integrated suite. You can do things like boards and gated check-ins and lots of approval processes and a lot of other things that just make it really tightly integrated with other parts of the product, so that you get a more full featured set of tools for doing automation and managing process for code. The main disadvantage of this one is the agents are just like, you saw that little tagline up there in my DevOps when I went to run it, that, oh, we're seeing regional performance impacts. That seems just to be constantly up there on the DevOps. Like every time I go there, there's always some issue with pipelines because they're so heavily used that it's hard to keep up with the demand. And so the agents can be kind of slow at times. And so they're not really good for large builds. So you don't want to use them for like Windows containers and things like that. Although you can build Windows containers on DevOps, not a recommendation. I wouldn't use it for that. I would probably use a hosted agent or use one of these other use like GitHub Actions or a container registry build for that similar task. So let's go back and look at our builds and see how they're doing. And this is our build and deploy from this is the one from the GitHub action. It looks like it ran just fine. Let's go close this window out and let's look at our other builds right here. This is the one from DevOps. It looks like everything ran fine there. I got a successful build there. And let's look at our ACR build here. It looks like everything's good here. So all three builds succeeded. So just by changing one thing in the repository, you can trigger 3 different builds. And if I look at my repositories now, I should be able to see 3 different repositories here inside of my Azure Container Registry. All right, come on, pull these up. There they are. So here's my one that I built with Azure DevOps. This is the one I built with Azure Container Registry tasks, and this is the one I built with with GitHub Actions. So I got 3 repositories, all from the same GitHub repo, using different methods for building images, and then I can manage all these, the output from all these, using Azure Container Registry for that. So if I wanted to turn content trust on, if I wanted to use monitoring metrics, all this stuff right here that are built in Azure Container Registry, now I've got a tool that I can do that with, and integrates nicely with my build pipeline. So let's take this, let's just, for good measure, let's just run this inside of a container instance so you can see what this container actually does, which is actually runs a little DOS game. So let's go over here into this resource group. And I'm gonna add an Azure Container Registry here, container instance, not registry. And I'm gonna do this using I'm gonna treat it like it was a third-party registry, because there's a bug in this right here. If you choose this for some reason doesn't work. I don't know, it just seems to crash. So I'm gonna use a private repository, and I can just plug in those variables that I got from Azure Container Registry into this, and it works just fine. So this is Azure Container Instances, which just allows me to quickly spin up a container without having to spin up Kubernetes. It's good for just creating a container in Azure, creates it really quickly, and allows me to spin up things really fast. So my image name is going to be that, and that's also the name of my login server. I need to get a container. Let's go ahead and get the username right here. There's the username, and here's the password. And let's just plug that in right there. And then let's go get one of those repositories right here. And Keen ACR, let's just use, yeah, we can use that one. I think that one should, let's make sure that this one's, yeah, that should be fine, latest tag. And I'm gonna do / Keen ACR. That's gonna be the one I built with an Azure Container Registry task. And that's the username, that's the password. This is the, sorry, that's the wrong place. That's the login server, and this is, there we go, that's better. Image name, login server, these are the credentials, and that size is fine. It's a Linux container. I don't need private endpoints, so I'm just going to kind of click through these next tabs and click create. And this usually creates within a few seconds, so that assuming I got all the things plugged in right. Looks like I was able to do validation there. So looks like that is up and running. So looks like we're chugging along fine here. This usually takes about a minute to deploy. And once that's done, we should be able to see our Azure Container Registry instance in the same resource group as our container registry. And so this will allow me to log into it whenever that's done. While we're waiting on this, let's go over to the questions, and let's just see what we have here. And maybe we can answer a couple of questions while that's running, and then we'll revisit this. So I'm going to answer maybe the first one or second one. First question that we have here is, can we do that with a private local registry? I'm assuming that Azure Container Registry, a build you can do with a local registry, a private local repository for build you can with Azure DevOps, and you could do that with a task. Can you do it with a task? I don't think so. I don't think that you could do that. So a local task would be the task. I think that the spirit of the question is can you use a local registry that is a private Git repo to trigger a task on Azure Container Registry? I don't think so, but I would have to look that up. I don't think you can though. I think that's limited to GitHub Actions. I'm sorry, GitHub repo or an Azure DevOps repo. What you could do is create a private repo on Azure GitHub, and GitHub, and I meant, okay, clarifying question. I meant instead on GitHub hosted repos. Sure, you can do that on GitHub hosted repo on a private repo. Yeah, you could definitely can trigger that with a task build, an Azure Container Registry task built by Azure Container Registry from a GitHub repo that is private. Yes, you can do that. That would be fine. You would still have to create a personal access token that grants access to it though. So that would be the downside of that. I think our deployment succeeded. Let's refresh the resource group here. There is our container instance. There's a couple of other questions here that we can look at. Here's my IP address. And I should see a list of HTML files. Oh, perfect. And connect to this. Let's punch in a password. Super secure. It's actually embedded in the inside of the Docker file, so it's password one if you're wondering. Install the game. This is a game running inside of a container and it's streaming the results back to a browser window. And so this is an old DOS game that is running on Azure in an Azure Container Registry, Azure Container instance that I built using a task on Azure. So I can play my old DOS games on an Azure container instance or Kubernetes or whatever. I mean, it's just streaming it back to a browser. So yeah, just kind of a fun little demo that shows you what I'm actually building there. So that's what we're doing there. Okay. So let's go answer the rest of these questions right here, and I'll try to. We have a few minutes left. About 45 minutes. It's 2:45. We have 15 minutes left. There'll be plenty of time for questions. The question that after the one about the private repo was, can I specify a branch? Will that trigger a repository task? Yes. If you look at, let me pull that up and let me redact this so it's not showing my my personal access token here. I'll show you what that command looks like, and pull this over here. So whenever you create that, everything after this hash right here is the branch. And so you can for the Azure Container Registry tasks, you can specify the branch basically just by putting a hashtag in the name of the branch. And so this one is using master, but because that's the only branch I have in that one. But if you wanted to put another dev branch to trigger that, you could definitely do that. So very easy to do there. Next question is will this presentation, can we have this presentation as reference materials? Absolutely. We'll post this to our YouTube channel, and I'll link to. I'll put it up on. I'll put this deck up in on a GitHub repo, and then I'll put that the link in the video description. So it'll be available on our GitHub channel, which is if you're curious about that, GitHub or YouTube channel /OneElect. Now I think like this right here. So you do youtube.com/OneElect now, and it'll pull up our YouTube channel, and it'll be under webinars, and we'll also send out a social media post as well for when it's available, so that you can get you can revisit it if you want to. So we'll post it here, and then I'll put a link in the video description so that you can download the deck. So that's good. Next question is when you are done running, how do you take that task down? How do you take down the task in an ACR instance? You delete it. You don't have to. Like the whole purpose of a task. Oh, that's an. The whole purpose of a task is you can delete it right here. That's how you can take it down if you want to delete the task. The purpose of a task, though, is so that you can have the repositories and do things like CI with container builds. So you want to have a container task that's using Azure Container Registry tasks to do that. So this is available. So if you want to delete it, just delete it. I mean, it's you don't have to keep it around forever. So when you're done running a task, how do you take down the ACR instance? The ACR instance is you can just delete the container registry from there. And the repository, if you want to delete that, you can delete the repository right here. And so this is how you can create webhooks. This is like I was getting at right here. For downstream tasks, for doing webhooks, for triggering things like deployments, if you want to do that with the ACR. Next question is, as you mentioned, DevOps is not suitable for larger builds. Is GitHub Actions more suitable for that, for WPF, with integration with test-based on .NET 4.5? Yeah, I think GitHub Actions would be better suited for that. GitHub Actions agents seem to be a little bit less taxed than the ones that they use for DevOps, and so they tend to work better. So I would use that for some of those larger builds. However, if you're using that was specifically related, like a WPF application with integration test built in on .NET 4.5 should be fine on DevOps. It's just if you're building a Windows container for that, it could be it could be bulky. And I've had mixed results with, when I say mixed results, unreliable results with building Windows containers on Azure DevOps, because the agents just seem to choke under load. And so if you're just building straight code, probably okay. But if you're building a heavy Windows container, I would probably go with a hosted agent for that, just so I could guarantee the compute would be there to build that image. That's just my 2 cents on that. It's just based on experience. Okay, next question is I'm never able to SSH into my containers on an Azure Web Apps. Do you know why? Thanks. I don't know. I would do that on an Azure Web App. Usually those don't run on a standard port. They run on like port 22, and they use a strange, if you're building a custom container, it runs on like port 2222, and you need to basically use one of the base containers that they provide. If you're building a custom container on Azure App Services, it's using Project Oryx Azure App Services. I think it's what it's called. This is to base all your images on this project right here, because these base containers are the ones that they use for Linux app services. And so everything on Azure App Services for Linux runs in a container, and then it's based on this project called Project Oryx. If you're not using one of these Project Oryx base containers for your images, then it could be you could run into problems. And if you go to Microsoft Azure Microsoft Docker Hub, it's going to give you, you should be able to see a bunch of images in here for Project Oryx for like various platforms like, Python or .NET, like this one right here. This is a Project Oryx container, so you can use a function app based on Node app. Okay, so that's one for that, for Linux. So you'd have to find a container here that matches the platform or the SDK that you're using, and use that for those containers. And that usually will let you SSH into it, because it's building an SSH agent on there, installing it, and using a proprietary username and password that is built into the image. It's not something you have control over. So if that's not there, it won't let you log into it, and that's why it might not work. And that's a long answer to it. I know, a very simple question, but that has always been troublesome. I've never recommended that you do. Never recommend that you do that anyway. Next question is, what's the best practice for using passwords in Docker files? Best practice is not to put passwords in Docker files. It's to use at build time is use build args. Like in a Docker, if you use something called build args in Docker files, if you need to inject a password in there, build arg right here. Basically, Docker file reference args right here is well, let's see if it's got a reference here. Predefined args, automatic args. But what that does is, I'm not seeing the documentation for it, but what build args is basically environment variables that only last the duration of the build process without carrying those forward into the actual container. And so env will carry environment variables into the environment whenever it's built, and then those get baked into the image. Build args don't do that. They just basically create environment variables for the life of the build, and then it uses then those get discarded. Now, when the container goes to run, you will want to use some kind of secrets management. So if you're using like Kubernetes, you use Kubernetes secrets, or you could use Azure Key Vault to do that, and you can use secrets management external to the container, and then when that container starts, you can point to the secret, and then that's injected into the container, usually as a file that you can read, and then you can get the secrets out of that for like username and passwords that way. So so as far as Docker files go, don't put passwords in Docker files. unless you don't care, which I don't care for that DOS box image. But if you're production oriented, don't ever put Docker passwords in there. You can inject those at build time using build args. And if you need to access a password at runtime for the container, use secrets management to handle that. So there's ways around that. Next question is what type of containers are not recommended for Azure DevOps? That's Windows containers, mostly big, heavy containers that have large image sizes. I've had mixed results. By that I mean unreliable results with using Windows containers built by Azure DevOps, because it just seems to choke under some loads. Smaller containers for Windows containers can sometimes work, but for instance, I was trying to build an IIS-based container the other day. Thing just choked. It wouldn't finish the build. Doesn't matter how many times I ran it. Sometimes it would get to the end, but it would just die on the push. Sometimes it would just die in the middle of the build, and for no apparent reason. So again, just some pointers there if you're looking for some tips on there. So big containers I wouldn't do. Smaller ones like this one, like I built here, not a problem. Linux, not a problem. The Linux agents on DevOps seem to be a lot better than the Windows agents anyway. They're faster, they just seem to run better. So for building containers in Azure DevOps, as long as they're Linux containers, you can rock and roll with that all day long. I've never had a problem with that. It's just Windows containers are the ones that I don't recommend it for. Next question is we have a few large ASP traditional applications running on premise servers. Is it better first to migrate those to ASP.NET Core and then containerize them for on Azure, or is there a better solution? By ASP, I'm assuming you're talking about ASP.NET, not classic ASP, and then migrate that ASP.NET Core. What path forward is really up to the app. I would have a hard time telling you what to do with that without yeah, somebody did point out something there. Mitch Harper said a concern. I'm going to answer references for a second. One caveat, FYI, build args can be logged. That is true. Using it would be insecure for secrets. A much better option for that. In Azure DevOps as well as GitHub, you can use secrets management for that if you need to inject those in there by way of other means. But build args, that is a good point. You can log that, but in the Docker file itself, no, you don't want to put any passwords in your Docker files. But going back to the question I was just asking about traditional ASP applications running on premise and servers, the path I would probably go with there is first try to put on Azure App Services and go that route, because if it's traditional, I'm assuming you mean a ASP.NET 2 or 3.5 app, web forms type application, that's traditional ASP. You can run that on app services. It might require a little bit of massaging depending on what you got going on with it. First approach would probably take it to app services. If that doesn't work, a container might work, because you could build a Windows container for those traditional applications with a little bit more control over the environment, because there's some caveats with taking some older ASP apps into app services if it doesn't fit the paradigm. Like for instance, logging to the drive is not usually a best practice. If you're doing that, then you kind of have to do some re-architecting to build a more appropriate logger, so it actually spits that out to a logger rather than just writing log files to the drive or writing to the root or something like that. Generally not supported there, but for that, you could definitely containerize that. That might be an approach. And then, of course, you always run it on a VM. I would probably go app services if it's not too much work, containers, and then probably a VM. Last question that I see here, but keep asking them. I think we have a little bit of time here. We got about 1 minute left, so we're about up the hour. Can you deploy containers for running automatic integration directly in GitHub Actions without Azure? Deploy containers running automatically. GitHub has GitHub has a container registry. So yes, you could use GitHub entirely. And that was kind of outside the scope of what we were talking about today. We're mostly talking about Azure related to container management. But yes, you could use GitHub entirely. So if you wanted to use GitHub for code repository tasks as well as their container registry, and then you could build a CD pipeline from that container registry into your runtime without ever touching Azure, yeah, that is possible. You could do it that way. So that would be one way to handle that. Again, there's a lot of ways to build containers, a lot of ways to host containers. I like Azure Container Registry just simply because it's so easy to use, easy to stand up, easy to manage, easy to use. Integrates well with Azure Kubernetes services, Azure App Services. It's got a bug in Azure Container Instances, but the rest of the stuff works fairly well. And then also works with Service Fabric and Databricks and Azure Batch and with Batch Shipyard and just everything that uses containers on Azure. Azure Container Registry just works really, really well. That's one reason I just love it about within the Azure ecosystem. So, well, let's see. Looks like we're out of time. Unless there's no more questions. I mean, thank you guys for coming out. I appreciate your attentiveness. I appreciate all the good questions. Thanks for asking those. Just so rehash, we will put this on our YouTube channel. I'll put a link to the deck there so you can reference that. And then of course, we'll be doing more webinars in this space. Thanks for coming, and looking forward to seeing you guys on future Winter Like webinars.